In this video, I'll demonstrate the prototype design pattern. This is another creational design pattern. You use it to create instances of objects, similar to the factory design pattern, but this works a little differently. With the prototype pattern, instead of calling a static method on a factory or on a business object, you create an instance of the business object, and then you call a method on it like clone that creates a copy of that object. In this example, we are going to create a monster object for a pretend role-playing game. Here's our monster class with two properties, a string property for its name and an integer property for its hit points. The constructor takes the name and the hit points as parameters and sets those parameter values to the properties. And we have a public method here called applyDamage, where we subtract a certain amount of damage from the hit points. To show how to use it, I have a couple of unit tests here. In this first test, I'll demonstrate a potential problem. Here we create a spider1 variable, and we call the new monster constructor to create it. And we create a spider2 variable that just points to spider1. If we test the two spider variables, we'll see that their hit points are both 10. Then I'll apply 2 points of damage to spider2. The problem we have is spider2 is not a new object. It's pointing to the exact same object as spider1. It's referencing it. So whatever I do to spider2 also happens to spider1 because it's a single object behind both of the variables. So if we check the spider1 hit points and spider2 hit points, we would see that they're both 8. To prevent the problem, you could call the constructor for every spider variable that you create, which is what we do in this test. So we say spider1 equals new monster, which calls the constructor and creates a new object. Spider2 equals a new monster, which calls the constructor again and creates a separate object. So now when we apply 2 points of damage to spider2, spider2's hit points will be 8, and spider1 will still have 10 hit points. This is one way to get around the problem with references. Just call the constructor each time to make a new variable. The prototype design pattern gives you a different way to do that. Here's a version of the monster class that uses the prototype design pattern. We have the same properties, the same constructor, the same applyDamage function, but we've added a new method on it called clone, which returns a monster object. And all this does is it returns a new monster, so it's going to call the constructor again, passing in the current object's name as the name parameter, and passing in the current object's hit points as the hit points parameter. So the new monster it creates will have the same name and the same hit points as the object you called the clone method on. If we look at it in a unit test, we create a standard giant spider, calling the new monster constructor. Then to create spider2, we call the standard giant spider.clone. This will call the clone method, which will create a copy of standard giant spider. But the clone method returns a new monster object, so we don't have the reference problem. After calling the clone method, we can check the hit points on both spiders. They're both 10. If we apply 2 hit points of damage to spider2, then spider2 hit points will be 8, and the original standard giant spider hit points will still be 10, because these are separate objects. This clone method is nice, but why would you actually need to use it? What's the purpose of the prototype design pattern? Let's say the constructor did something that was going to take a long time to complete. So for this example, our monster class, in the constructor, we're going to load up a loot table for the monster, which is just the potential items it might have in its inventory and what the drop percentage is. And this loot table entry is just a simple class with an item ID and a drop percentage. This will be used to populate the loot table list, so when you defeat the monster, you'll know what kind of items you can loot from it, what you can grab from its inventory. Here I'm populating the loot table property by just manually inserting some manually created loot table entries. But for a real game, you would probably populate this from a database or a data table somewhere, and it may take a little while for it to load. That's something you wouldn't want to call every single time you create a new monster. So here, I created a second constructor that takes the name, the hit points, and the loot table value. So the clone method, when it creates a new monster, passes in the base monster's name, the hit points, and the already populated loot table. This goes through the private constructor here and populates the loot table property on the new monster with the passed-in parameters, so it doesn't have to call the database a second time. This makes it much quicker for us to create additional monsters, because we don't have to hit the database every time. Now, it's not a requirement of the prototype design pattern that you have this private constructor. This is just really the most practical situation I can see where you would want to use the prototype design pattern. When your constructor is expensive, when it uses a lot of resources, when it hits a database, when it needs to calculate or set up or initialize a lot of data, this is a way to get around doing that every time you create that type of object. And also, your clone method does not have to be called clone. That's just the most common name to choose for it. You could call it create new instance, make copy, whatever you want to. Really, all you need to do to implement the prototype design pattern is have some sort of method you can call on an existing object that will make a new object that looks exactly like the previous one. That's the idea. The first one is the prototype for any subsequent objects you create. You could use the factory design pattern to do the same type of thing. And the first time you instantiate a certain type of object, you could have some static variables that hold the initial values. You initialize it the first time you instantiate that type of object, and any subsequent objects, you check and see if the values are already there, and if they are, you just populate. That's another way to solve the problem of having a constructor that is expensive, that does a lot of work. But it's worthwhile to be familiar with the prototype design pattern, because you may run into a situation where this is the best solution. If you have any questions, please leave a comment below or look in the description for a link to the support page on my site. Thanks.